Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will discuss about query by example. We will see what is a query by example, what a skeleton table, how to introduce a query using the QBE, how to insert conditional statement, programming construct in QBE, and how QBE is handled in different types of operating systems. Query by example or QBE is a combination of a data manipulation language as well as it serves as a database system to most of the operating systems in nowadays. Now it has two distinct features over other query programming languages. Now the features are, firstly, query has got a single dimension, but in the query by example language, we will have a two-dimensional way to present it. And now we are talking about two-dimensional way, then we can say that not only we are having it in a table form, but also we can have two of this dimension using for the value as well as the attribute definition in an QBE. The next distinct feature that we use in an QBE is, as the name suggests, we use all the queries not by any procedure or definition or methods. We use it by example. That means it is a direct representation of a particular enterprise. Say the QBE of bank will be different for the QBE of a college, will be different from a QBE of an IT sector job. So that we can have to construct the QBE or the basic syntactical QBE for each of the enterprises. Now it goes with another disadvantages too, that we cannot just have a general QBE that we can apply to any of the enterprises and have made their own QBE. So we have to construct each of the enterprises QBE differently from one another. So it is basically as based on examples, then we can satisfy all the needs of particularly that enterprise and not just enduring other properties that will not needed by the particular enterprise. So query by example is a general form of solving query by examples of an enterprise. So now we will look at what are the skeleton table that we can form in a query by example. Now, if we are looking at the bank enterprise where we got the departments, so two of the depositor and loan, that are the relations that we need in a bank relation as well as many other relations. We are considering here only two for our example solving. Now the skeleton table means the attribute names that can we have as part of the query. See, Microsoft Access often use this query by example as a part of its database. Now query by example means we have to choose the query on a particular attribute. So the skeleton table looks like the relation and it's along attribute with it. So whenever I'm having the attribute, I can put a condition or any other predicates against that attribute inside the cell that is marching with a column and intersecting with a row. Now when we are talking about skeleton table that does not contain any value, any predicate, that only contains the relation name and all the attributes that we can have inside that relation. Now often in some implementation we can allow the opportunity to choose among the attributes that we need as a query. Say for an example that I need only the ID and name and my predicate will also deal with the ID of that particular relation. Then we no need to insert all the attributes on this query by example. We can have just two of the attributes ID and name as a skeleton table for the query solving part, also as the output of this QBE. So now let us take an example and see how the skeleton table looks on a bank enterprise. Now this looks like a skeleton table on a loan relation on a particular bank enterprise. As it solves by example, so we are having a loan as an example of a relation. Now the left hand side suggests the relation name, which is loan here. Now I will introduce only the attributes that I need to solve the query, not by just creating clutter to all the attributes in a skeleton table. So we have put the loan number, branch name and amount as the attributes to need in a query. So say we will solve now the queries in a single relation. So how to query solving in a single relation? Say that in a skeleton table, we need to keep in mind that all the variables should precede with an underscore sign to denote that it is a skeleton table query solving variable. The variable name cannot be used as a normal variable inside a SQL query or any other fetches data. So if x is needed to be solved, then we must precede underscore x as our variable to the skeleton. So now we are solving the query that I want the loan number and branch name of that particular department. So first we need to introduce P as our first thing, then precise by the dot, after that underscore x as the skeleton variable. So the branch name here is Perry. Now I want to fetch the loan number of the branch name Perry, so I can have it by p dot underscore x, but the branch name is Perry. So this is a query by example solved in a single relation. Now let us look at more examples. So for the bank example, we will see first all the skeleton table that we can make, and next we will solve that what are the queries and what are the features of QBE. So for this one, we can write the corresponding tuple relational calculus along with this way. Now here we can look at that B, which is XBA, represent the loan number, branch name and amount to our loan relation. So XBA belongs to loan, and the B part we are using the domain relational calculus, so we need to specify the attribute name B as Perry. We can rewrite it in tuple relational calculus too, but that is not the concern here. First we need to know what are the skeleton tables that we can deal with in a bank example. So let's look at the skeleton tables that we can provide in a bank example. The last one we have seen that the loan table, which has got the loan number, the branch name and the depositor name. Now we got the branch relation that is consisting with the branch name, branch city and assets of it. Then the customer relation having customer name, customer street, city and postal code. Borrower name or the borrower customer name and the loan number to which the customer is borrowing. Account relation with account number, branch name and balance, and the depositor relation to which customer is depositing and to which account number. So these are the skeleton table that we will use in our relations. Now that query by example considers all the null values as all values in the example. So if someone is specifying p dot space, then it is equal to consider p dot all for that particular example. Now if we are taking that p dot space for our example, then all the values contributes on the attribution are being considered as a part of that consideration. So let us take an example and see how to write in a null value that is equivalent to a all part. Now let's look at this example. If p dot and branch name Perry is given to us, then it is same as writing p dot all Perry. And this query by example will result in all the loan numbers that has got branch name Perry, and this will also result in all the loan numbers that has got branch name Perry. Now if I want to display that all the details of a loan relation, then we need to push just p dot here. So other than using this one, I can use the loan relation P dot to display all the relation of loan number, branch name, amount, that is the resultant table on the loan relation. Now we can also have some conditional checking on this way. Now entire relation will be considered again, and we can have checking that if amount is greater than 700, then I want their loan number, branch name as well as the amount paid to them. So for that I need to perform. Now say I want to display all the attributes of loan relation that has got amount greater than 700. So I need to write P dot here as to signify that I want all the relations. Now the amount is greater than 700, so I can have it just like. So this one can have constant as well as a variable or a constant combination. So I can also write. So now I want the query that P dot, that means I want all the loan numbers of some amounts that is considered to be the variable of summation x and y and then minus 20 to it. That means x and y variables value will be given to the user, and then we will subtract from the summation 20. So as the result, what we will have, we will check against it the amount. If it is greater than the result, then we will fetch all the loan number against it. Now let us solve a query by QBE that I want all the city that doesn't belong to Brooklyn and the customer information of that. So first we need to select the cities other than Brooklyn, and then I need to select all the informations on that particular customer. So here I need all the branch names of the city other than Brooklyn. So as we need all the branch names, we can put P dot here, as P is a well-composed formula. Now to define that not Brooklyn is, we can simply put not sign before the keyword Brooklyn here. So it will first address to all the cities that not match with Brooklyn, and then select the branch name that matches with the branch city. Now we can say that this becomes very small and simple, as we do not want to write that the branch name and the branch city matches, then we want to select. So QBE very user friendly, and it also very convenient to use. Just we need to put a composed formula PQR and then the condition based on which attribute just below the attribute field. Now the main purpose of QBE is to solve and take use of the variable on the QBE. As I have previously said that the variable on QBE must be signed with an underscore sign. Now when the QBE is using a variable, then we can use it in separate of two conditions. Let us solve a quick example and see what is the difference between solving it with QBE and a tuple relational calculus. Now say for example, I want to fetch the information that which loans are jointly borrowed by Smith and Jones. So here the customer name, so it consists both Smith and Jones, and now I want to fetch a variable which will consist the Smith's loan number as well as the Jones loan number. So in this way we can use of the variable in QBE and store value for both Smith and Jones or two different queries in a single variable, other than using it two queries for this purpose. Let us first write it in QBE. Now as I have said that the customer should be Smith and Jones jointly taking the loan, so I can use Smith and John as two different query input on the customer name Smith and John. Here I am not using the all operator or the null operator. Now I want to take the Smith's loan number as well as the loan number on this John. See, I have used the P dot only once because it belongs to a single query, not to different queries. So the X will store the Johns, as well as if it is matches with Smith, then it also stores the Smith. So now I have the loan number of Smith and Johns. Now if I have to write it in domain relational calculus, it would have been a long query. Let us see that how to write it in a domain relational calculus, which will be definitely a combination of both the two queries. Now see, it is a combination of two queries. First one is the Smith's information, and then we are having the AND operation to fetch the intersection with the John's operation. So if this two is matches, I'll find the loan number. Now it is using a single variable x. Let us look at some more complex problem which will involve more than one variable. Say for an example, I want to fetch the information of the customers who lives in the same city John resides. So now I need two information, the name of the customers who lives with John and also the city that in which John lives. So I need basically two variables that I will use in the next query. Now see, in this example, we are solving that first fetching the John city, then matching with the customers that we want to fetch with the city that John is living. So first I am fetching the variable underscore y, then with the help of that y, I will use to fetch all the customer names that matches with the customer city underscore y. So we can use two variables in a query by example like this. The next I will use that the examples from two relations. Now when I am talking about two relations, I need to join it by a Cartesian product of that relation. In query by example, we can just put two different relations into skeleton tables and then have a joining or common variable of it which will join these two relations other than using any natural join, any outer left join or right outer join or full outer join. Just two skeleton tables and a common variable or two common variables which will handle the joining between them. So we can fetch data from both of the relations or a resultant of both relations. Now we will see that how to perform a basic query on more than one relation. So for our join relation, we will solve it with an example that I want to fetch all the customer names who is a borrower from Perry Ridge branch. So here I need two information. One is from the branch, another is from the loan. So the two will be merged and common by checking the loan number. If the borrower's loan number is same as the branch roll number, where the loan number of the branch is matched with the branch name Perry Ridge, then only we can fetch the relation as a resultant one, which will consider all the customer who is a borrower to the Perry Ridge branch. Let's just write it in query by example. Now here, as the condition satisfies that the branch name is Perry, I want to match the loan number with this loan number of the borrower. And I want to fetch the customer name. See, the underscore x suggests that I will fetch only some part of the customers, not all the customers. And the underscore y, loan number of the loan relation and the loan number of the borrower relation should match in this case. Now as we have a Cartesian product on these two relations as a result of this joining, now we can fetch all the records on the relation as a resultant joined relation. Let us see with a more complex example. I want to fetch the customers who has a loan and both an account in a branch. So now also I need an account information and a loan information. Let us see how to solve it. So here I want that the customer names who has both a depositor and a borrower. If a customer has an account in the bank, then he is a depositor. If he has a loan number in the bank, then he is a borrower. So these two must match. We can use either into place the P dot and other will match with it. Now let us see this example by just reversing it. I want the customers who has an account in the branch but not a loan in the branch. So we will need to configure it just by reversing the order. So we can just put a not sign inside the relation name. See, when I put the not sign under the relation name, it signifies that it consists no tuples on the matching attribute of customer which has a match on this depositor table. So the depositor table can have all the tuples and the borrower table cannot have not a single tuple within this not operator. So the not operator under the relation name suggests that this is not having a tuple. Now how to use or what happens now when you put this not operator under the attribute name rather than in a relation name. Now we will solve an example to see that how to use a not operator under an attribute name. Say for an example, if I am finding the customers who has at least 2 accounts in our branch. So how to solve this using a query by example? See here, I want to fetch all the customers who has at least 2 accounts. At least 2 accounts means if the customer name reposits or repeats in the depositor name, depositor relation, then the account names must not match with each other. So if there exists a p.x in a customer and the same is repeated on a customer field of the depositor relation again, then this y must not match with the second y. So if the first account number is stored in variable y, then the second account number must not match with variable y. So here we are using the not operator under the attribute name of a relation. So when we are using the attribute name on this not operator, it is actually specifying not equals to, rather than when you're using it under the relation operator, it is of no selection of tuples. Next, we will move to our next discussion part, that is the condition box on an QBE. Say suppose for an example, we will use an QBE that contains more than one conditions inside a single attribute. How to pose these QBE attributes in a query? We will use a condition box other than the skeleton table and precisely attach with the skeleton table to specify that which attributes has got which condition specifiedly. So in the attribution field, we will use only a variable name, and the variable name will be referred in the condition box to specify what condition we are using. Say suppose I want to find the account number of having customer John on Smith. So how to write this one? Now say I want to fetch the loan numbers on if the Smith and Jones is having jointly the loan, or it belongs to Smith or it belongs to John. Now we will use an OR operator obviously here, but I will use only a variable name n and the loan number as our result, and in the condition box we will write that n can belong to Smith or it can belong to John. So rather than writing it here Smith and John, we can write it like this, because if we write Smith and John here, it will put the loan numbers of which belongs to both Smith and Jones. So using an OR operator, we can specifically use it in a condition box. Let us look at more complex example to use a condition box. First, we will find the account balance is 1300 and between 1500. So we'll fill on the information on this. So I want to fetch the account number of the balance that is between 1300 to 1500. So I need to fetch the account number and I will use the balance as my variable, where in the condition box I will write that the balance is greater than 1300, the balance which is less than equals to 1500. Now say I want to fetch the branch name which has asset greater than any of the branch that is at least one in the Brooklyn branch. So we are finding all the branch names that has asset more than one, that is one at least having in the Brooklyn branch. So how to find it? So here I need the branch name, so I will use an variable to get the branch name, and I have mentioned that the city of Brooklyn should have the least number of assets. So I have mentioned Brooklyn here. Now, any asset that we are considering as Y and the Brooklyn asset that we are considering with Z. So my condition is the assets from branch name X should be greater than the branch name of Brooklyn. So the simple condition is that Y is greater than Z. Now we will use the most type of the complex in the conditions variable. Now I want to fetch the branch names that has asset that is at least twice as large the asset that has got any branch in the city of Brooklyn. So the same way as goes with I want to find the branch name. Now my city if is Brooklyn and the asset is Z and all other asset is Y. So my Y should be at least twice greater than the Z. So see here we can perform complex arithmetic operations also in this condition box. So I am using greater than equals to as in comparison operator, star as in product sign of 2 into Z. So I can use even the constant, the variables and the relational operator. Next, I want to fetch the information that I want the account numbers on the bank who has got the money or the balance between 1300 to 2000 but not 1500. So I want to use a combination of a predicate as well as another predicate that will check that if the balance is 1500, even it is between 1300 to 200, I will just omit it. So how to write this one? So I want all the account numbers based on the condition that the balance is between 1300 and 1500 but not equals to 1500. So I want all the account numbers based on a balance variable. So the balance see here I have used the previous conditions along with the condition that balance is not equals to 1500. Now I want to fetch the information that the city on Brooklyn or either of these another cities. We want to fetch all the information on that. So how to use it inside a condition box? So I all want the branch name if the variable is the branch city. So if branch city belongs to either Brooklyn or Queens, I want all the branch names. So I can just join the two names that we are using to fetch on the branch city and have it as a variable set, and the variable set can be used against to fetch the branch names. So that are all for the query by example skeleton tables and conditions tables. The last part that we want to see of a QBE is a result relation. How to fetch a result relation from a query? Say suppose I want the customer number, branch number, loan number, account number of a particular customer. Now I want to fetch it using the query by example. How can I do that? First I need to join the two tables and then use all the predicates on that table on a resultant relation to have the result. Now in query by iteration, we first need to mention the table names as a skeleton table. So the first step is to create a skeleton table and then join it with the conditions and then finally write a query to find the result relation. So how to write it, I will show you. First, let us make the skeleton tables on joining the two relations. Now we want to fetch the account number, balance, and the customer number and the account number on that particular branch name is equals to Perry. So I want to fetch account number, balance, and customer. Now I want to match this account number with this one. So this must be Y here. And my query is the branch name is Perry. Now how to write the result query? I will show you. So my result query will have only the fields customer, account number, and balance, which are the desired query for our relation. So I want to fetch all the tuples from the result relation, which will consider the customer number variable, the account number variable, as well as the balance. So in this way, we can actually use the result query to fetch the final resultant relation. Now, how will query by example applied in Microsoft? Well, Microsoft Access is the database management system that it uses, and it obviously uses query by example. It also uses a query written, but for a graphical designer purpose, it uses the query by example. There are many facilities like we can select a tick over there so that I can choose that which one I want to add in our query by example engine. We can just put the conditions here other than writing in a condition box separately. And these are the advantages that we can use in query by example of an Microsoft Access query. We can design it with a design wizard or manually as per our choice. Now we will add this all examples on an attributes on Microsoft Access and can perform the query by example as a result. So that is all for query by example. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.